Hello everyone. We are starting with the lecture on CF graph, cumulative frequency graph. Now what exactly is a cumulative frequency distribution? Let's have a look. I have a column for class boundaries. I have a column for frequency. The class boundaries are of equal width. Even if it was unequal width, it won't make a difference for our calculation for cumulative frequency. The table is all filled up. The class boundaries are ranging from 5 to 10, 10 to 15, all the way till 35. The corresponding frequencies are 3, 5, 9, 4, 2, 1. Now let's assume for a second that this class boundary is actually the number of minutes that a student takes in order to reach school. So this is number of minutes taken by students of a particular class in order to reach school. Now how would I read it? I would read it as there are 3 people who are reaching school between 5 and 10 minutes. 5 people, they reach school between 10 to 15 minutes and so on. Now what I'm doing now is that I'm taking the upper class boundary of each class, which is 10, 15, 20, 25, 30, 35. And I'll make a column for cumulative frequency. Cumulative means added up. Now the upper class boundaries are such. For the very first upper class boundary, the value is 3. What does this 3 means? This 3 means that there are 3 people who are taking less than 3 minutes in order to reach school. For the next upper class boundary 15, it will be 5 belonging to 10 to 15 group as well as the 3 belonging to the previous group. So therefore, that's where cumulative frequency comes in. You have to add it up. So 5 plus 3 is 8. That means lesser than 10 is 3. Lesser than 15 is 5 plus 3, which is 8. You are basically adding the previous frequencies. Now, what would be the answer for less than 20? It should be 9 plus 5 plus 3. What about lesser than 25? 4, 9, 5, 3. Add it up. Lesser than 30, 2, 4, 9, 5, 3. And lesser than 35, everything. Everyone in that class naturally is reaching school in less than 35 minutes because that is the maximum time limit. And that's how you create a cumulative frequency table. So in order to draw a cumulative frequency graph, you need to create a cumulative frequency table. That thing is done. One other thing is the sum of frequencies is 24. This 24 should exactly match with this 24 over here. That means the last cumulative frequency should correspond to sum of frequencies. Now, if I take a graph paper, and on the graph paper, I label the vertical axis and I've labeled till 26, even though my final frequency was 24. So that's not a big deal. And then I label the upper class boundary 5, 10, 15, 20, 25, 30 and 35. And I mark 6 dots over here. Now these 6 dots are marked. And if I were to join them, there is something missing. That something missing is if I join M using straight line portions. So that would be like this: straight line, straight line, straight line, straight line, and straight line. These are straight line segments. Now it's hanging in mid-air. It should touch the ground level. It should touch the x-axis. Should I make it touch the 0? The origin, or should I make it touch 5? Now that is a question that we have to look for. We have to look for the answer for this. The rule is, in the very first class boundary, which is 10 to 15, the lower class boundary is 5. Listen to my words again. In the very first class boundary in the frequency distribution, the lower class boundary is 5. According to this data, is there anybody in that particular class whose commuting time to school is lesser than 5 minutes? According to the data, the answer is no. That means you would write a 5 over here, and you would write a corresponding cumulative frequency of 0. That means according to the data, there is no one in this particular class who is reaching school in less than 5 minutes. So therefore, now we got the answer that we should join this straight line to the point 5. So that's where the straight line should be joined. So let me first mark the point 5, and then let's join the line like this. And that's how you draw a cumulative frequency graph. Since straight line segments are used to join the points, we say this is a cumulative frequency polygon. Now, do not confuse this cumulative frequency polygon with the frequency polygon. Frequency polygon is something like this. When we look at this graph, a histogram is drawn. You join the endpoints, you join the midpoint of the top of those rectangles. So you see the blue dots? Now join those blue dots with straight line segments like this. And where should it end? It should end because this width is 1 unit. So therefore, it would end like this. So therefore, this green line is showing that whatever this distance is, that should be the distance over here. Whatever this distance was 13 till 16, that was 3 units. So this should be 3 units. So that's how you draw a frequency polygon on a histogram, or maybe without a histogram. Now, if we move back to this cumulative frequency curve, when we join it with straight line segment, that is called a polygon. If I join this using freehand, just a curve like this, this is going like this. It's not going to be very exact, like this, and so on. Make the points a little bit visible by drawing circles around it. So this is also a cumulative frequency graph, but since freehand joining is used, this is called a cumulative frequency curve. The name of this cumulative frequency graph is ogive. So this is like an S-shaped graph, and that's the characteristic of this. Now, why have we used the upper class boundary? When we use upper class boundary, the keyword that we are using is less than. Read the table again. There are 5 people, actually 3 people reaching the class in less than 10 minutes. There are 8 people reaching the school in less than 15 minutes. There are 17 people reaching the school in less than 20 minutes, and so on. So the keyword is less than because we are using the upper class boundary. Now, the graph is drawn whether in the form of a polygon or whether in the form of a curve. Both these graphs are known as ogive. It's a S-shaped graph. Let's move on. Again, this graph is there. And now the key thing that I want to explain is that vertical axis will always be cumulative frequency. In a histogram, the vertical axis is frequency, or in the case of a histogram with unequal class width, it is frequency density. Now, in cumulative frequency, it doesn't make a difference whether the class widths are equal or not. The graph has nothing to do. The vertical axis will always be cumulative frequency. It has nothing to do whether the class intervals are of equal width or not. Yes, it is a must that we should be working in boundaries rather than intervals. So when a question comes in which data is given, be very, very careful. Read carefully. First check whether it's boundary or class interval. Now, we all know that Q1 means lower quartile, Q2 means median, Q3 means upper quartile. We know that 25% of the distribution lies below the median. 50% of the distribution lies below the median. 25% below lower quartile, 50% below median, 75% below upper quartile. Now the word below is the same thing as the word less than. So the word below means the same thing as less than. Now keep that in mind. That means in this cumulative frequency graph, if I want to find out what is the lower quartile, what is the median, what is the upper quartile. So first of all, I need to check one thing. A lot of people are deceived when they look at the last value being 26 and they think that the cumulative frequency in the scenario was 26. It's not 26, it's 24, because that's where the graph is ending. So the graph is ending at 24. That is why skip this 26 out. That's the first thing you should do. Second thing, 1/4 of 24 is 6. Half of 24 is 12. 3/4 of 24 is 18. That means using the value 6, I would be able to find lower quartile using 12. I'll find upper quartile using 18. I'll find 12 will give me median, 18 will give me upper quartile. So let me first find the median from 12. I draw a vertical line like this. And that line should be dotted. And then this line would go down somewhere like this. And then I can use a ruler, an eraser to erase the extra parts. Now from this table, I can see that the value is approximately 17. So the median value is 17 over here. If I want to find out what is the upper quartile, I'll draw it corresponding to 18. So this 20 is like this. Let me just double check. This is 20. So 18 would be somewhere here. You draw till the graph. You go down. And then, of course, you can draw it dotted like this. And this is the upper quartile. And the upper quartile is approximately 21.5, approximately like this. So therefore, the upper quartile is 21.5. And similarly, you can draw dotted lines and find the lower quartile. So that thing is done. Now let me change the data, and now the cumulative frequency is the same as before, and on the horizontal axis I'm taking the marks. Cumulative frequency is the number of students in the class. Originally our data was for that. Cumulative frequency was still the number of students, but the upper class boundary was the time taken in minutes to reach school. Now I'm using the same data and I have changed the time to the marks. Now my first question is, find the number of students obtaining less than 17.5 marks. So the keyword, look for the keyword, that is 17.5 marks. So this is less than 17.5 marks. Then it says find the number of students obtaining more than 32.5 marks. So now the number of students are the cumulative frequency, and I want the marks. Over here the keyword was less, over here the keyword was more. Let's see what difference does it make. For 17.5 marks, somewhere here is 17.5. I reach the graph, I go left, and what I am getting is the value 12. That means there are 12 students who obtained, there are 12 students who have obtained lesser than 17.5 marks. That thing is done. Now it says obtaining more than 32.5. Now let me go to 32.5. That's like this. And go left. Let me go a bit up. So this is 32.5. I'm going left. And this is approximately 23 because I have to round it up. It's the number of students. So this is 23. Now the wording is, the keyword is less than. When you use the marks to get the cumulative frequency, that is the number of students. So what you are getting is that 23 got below 32.5 marks. Am I right? So 23 got below 32.5 marks. How many students are there all together in this class? 24. Therefore, the total minus 23 got more than 32.5 marks. Therefore, there is only one student in the class who obtained more than 32.5 marks. Let's recap the concept. The concept is we are using the horizontal axis to find a value on the vertical axis. Listen to it again. We are using a value on horizontal axis to find a value on the vertical axis. The value on the horizontal is marks. The value on the vertical is number of students, the cumulative frequency. If it's about less than, as in the green line example, read directly. If it's about more than, read that value and subtract it from the total. For example, in the purple line, lesser than 32.5 marks, there were 23 students. Altogether, the class had 24 students. So therefore, the difference is 1. That means one person got more than 32.5 marks. So this thing is done. Now, two more questions again on the same principle. 6 students got lesser than M marks. Find M. Now, what is the scenario over here? This time, the scenario is that we have students, we have the cumulative frequency, we have the Y value, and we are looking for marks. Marks are the upper class boundary and marks are the X values. So we are looking for the X values. Is this thing correct? Now, over here, again, the key word is lesser. There are 6 students who got lesser than M marks. Let's first go to the graph. So when I go to the graph, and if I go till lesser and 6, so this is 6, touching the graph, going down on the x-axis like this, and then making sure that this thing is dotted so that the examiner does not have any reason to deduct any marks like this. So I'm labeling over here 6 and going like this, and this value comes out to be 13. That means there were 6 students who got below 13 marks. So the value of that alphabet M is 13. Is this thing clear? So it's a direct reading because of the word lesser. Now it says 4 students in the class got a distinction. Now we know that the top hierarchy in a class, the elite, they get a distinction. They obtain more than a mark. That's why they get a distinction. Now, if 4 students got a distinction, and if I go over here, and if I go to this 4, that does not make any sense. I mean, is the class getting a distinction on like maybe 11 or 12 marks? Of course not. That means, what is the flaw in my working? The flaw in my working is that the distinction mark, those 4 people should be getting above a certain mark. That means if I label it again, I'll write 4 got above a certain mark, the distinction mark. That means, how should I rewrite it again? That means 24 minus 4 got below, lesser than the distinction mark. That means read the graph for 20. So first of all, erase this 26. That's a distraction. So go till this value, which is 20, which is this. Go left. Actually go right. Starting here. Touching the graph. Going down. Making sure that things are dotted. Like this. Now this is coming out to be 23 approximately. That means the minimum mark needed to get a distinction is 23. So there were 4 people who got above 23 mark and 20 people in this particular class who were unable to score that mark. Therefore, they were unable to score a distinction. Recap it again. Lesser, direct. Greater, something to do with subtraction. That means in the first part, it says find the number of students obtaining less than 17.5 marks. We went to the graph and read 17.5 and read the Y value directly. But when it says find the number of students obtaining more than 32.5 marks, I read the value, that was 23. 23 got below because the CF curve is based upon the concept of less than. It's based upon the concept of upper class boundary. So it will always give you values lesser than. So 23 people got lesser than marks. Therefore, 24 minus 23 is 1. 1 person got above that. When we are reading from the vertical axis to the horizontal axis, from CF to upper class boundary, in this scenario, from students to marks, what do? 6 students got lesser than n marks, so go to 6 and read off the value. That came out to be 13. But 4 students in the class got a distinction. 4 got above a certain mark. So I cannot read for 4, and that answer itself will speak for itself. It would be unrealistic. 4 students got a distinction, 20 did not. So read the graph for 20, and that's how you get the answer. Now, so far, what we have done is that we have talked about these 4 basic questions. We have talked about median and quartiles, the difference between cumulative frequency curve and cumulative frequency polygon, and the basic of it all, that was creating a cumulative frequency distribution out of a frequency distribution, and the examiner could ask for it vice versa. So that is the basic that we need. Let's move to exam type questions, the past paper questions. This is June 2017, Annabelle measured the length in centimeters of 200 caterpillars. Her results are illustrated in the CF curve below. Now, the very first thing that I, as a candidate sitting for the exam, whether in O-level math or whether in S1, would check that is this final value corresponding to this? Yes, it is. That is the first thing. The lowest class, upper class boundary is 1 and it's going till 5. This is a CF graph. Technically, it's a CF curve because it's a ogive joint drawn by joining by freehand. And then it says, estimate the median and interquartile range. That is easy. Estimate how many caterpillars had a length between 2 and 3.5. Let's see to it how to do this. Okay. Between 2 and 3.5, what we do is that we go till 2 and we go to the curve. I think there is a better curve. Yeah, this one is better. So let me go like this and go to the left. And let me go till 3.5. Where exactly is 3? This is 3 and somewhere here is 3.5. Okay. So this is 3.5. Like this. And then go to the left. Now what do we observe? We observe that this thing is, let's check the labeling. That is 10, this is 40, so this is like 10, this is 20, this is 40 is this one, I think. Let me just check it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is 40. That means 4 units each. So this is 1, 2, 3, 4, 5, 6. This is 24. And therefore, over here, this is like, this is 120, and this is 120, 32. Therefore, 132 caterpillars, they have a length less than 3.5 centimeters. And 24 caterpillars, they have a length less than 2 centimeters. Therefore, the difference would be 132 minus 24, which is 108. 108 caterpillars, they have a length between 2 and 3.5 centimeters. That thing is done. Then it says 6% of the caterpillars were of length L centimeter or more. That more question came in. 6% is L centimeters or more. Therefore, 94% of caterpillars will be of length L centimeters or less. Now here I brought in the keyword less. Now 94% of 200, that is 94 over 100 into 200, that is 188. So therefore, I should go till 188. And let me go on this curve. So 188, let me draw a blue one. This is 200 and then 4 and 4 and 4. So here, something like this. You read off this value. And this comes out to be 4.4 approximately. So 4.4 centimeters. That means the answer for this value of L is 4.4 centimeters. So that's how you try out a question, an exam type question in which the graph is already drawn. Now, this question, cumulative frequency. Now, this is 1000 is misleading. 1000 is referring to this value. But it's ending at this one, which is 900. So your working should be based upon 900. That is the first thing. 2 different weird looking graphs are there. They are not the perfect ogive. And it says the birth weights of random sample of 900 babies born. Okay, there it makes it clear. 900. Born in country A, born in country B are illustrated in the CF curve. Use suitable data from this graph to compare the central tendency and the spread of the birth weights of these two set of babies. Measure of central tendency is mean, median, and mode. From the CF curve, I can talk about median. This is country A. So this is country A, country B. I can write down the value of median for both from the graph, and I can calculate the upper quartile and the lower quartile and subtract, and I can find the interquartile range. So basically, the examiner will give you 1 mark for this median, 1 mark for this median, 1 mark for finding Q1, Q2 and subtraction, 1 mark for finding Q1, Q2 and subtraction,